So now we have a basic idea of what is stress, what is strain, plus the interrelationship between stress and strain from Hooke's law. Plus we have also studied the stress strain curve. So when you talk about Young's modulus, you basically talk about the region where the stress and strain were proportional to each other. Say this was your y-axis, this is your stress, and this was your strain. So you are basically concentrating on the region that was proportional. This was a straight line. So you are concentrating on this particular region while you study Young's modulus. That is the modulus of elasticity. So what is modulus of elasticity? I have used the term modulus of elasticity. Modulus of elasticity. So if in your examination this question comes, straight away simply write is the ratio between stress upon strain. And this is called as modulus of elasticity. Now this particular ratio is very important. This ratio is very important. The reason why is because it is the characteristics of a material. It is a characteristic of a material. So from here you come to Young's modulus. This is known as Young's modulus, given by the scientist Young's modulus. Now, Young's modulus tells us y is equal to stress. Now, this symbol is for stress. Please keep in mind this symbol is for stress and this symbol is for strain. This symbol is for strain. So, Young's modulus tells us y, modulus of elasticity. This is the modulus of elasticity or Young's modulus. Now, stress is what? F by A. For Young's modulus, I have stress to be F by A and I have strain to be the length, that is del L upon L. So, this is what I can write. Now, area is, say suppose this is a sheet, length into breadth is your area, and if you are talking about just length, then we are talking about just one dimension of this sheet, just one dimension. Say suppose there is a force over here, there's a force over here, the change in length because of this two, this is known, and this is the resulting strain, that is the change in length. So we know what is Young's modulus, and this formula can be further simplified as Young's modulus is equal to F into L divided by A into del L. So this is the Young's modulus, and if you talk about the dimensional quantity of Young's modulus, now please keep in mind in an examination you should also know the dimensions. Now it is very easy to calculate the dimensions of a particular expression because you know F is what? Newton. We know the unit of force is Newton, and this is L. So length is in meters, so this is also in meter, divided by this is in meter square into this is also in meter. So this meter gets cancelled. So Young's modulus actually gives me F, that is for Newton, and A, that is for area. This is not F by A, this will become pressure, but the unit is matching with pressure, that is Newton per meter square. Newton per meter square. This is actually the unit of Pascal. Now this was given after the famous scientist Pascal. So this is Pascal. Newton per meter square. This is per meter square. This is Pascal. Pascal. This is Pascal. Now Pascal is also the unit of pressure. This is also the unit of pressure. So Young modulus in some way gives us a vague idea of what is pressure. How much pressure can a body take? This is what Young's modulus is pointing into. But please keep in mind, Young's modulus is not equal to pressure, but something that we can think of as how much can a substance take pressure. So this is what Young's modulus actually talks about.